Okay, I'm going to walk through this first example to be sure we're all on the right track. Reading the problem, we see the number of iPad units shipped globally has been increasing year over year. The table displays the number of iPad units shipped globally for the years 2017 and 2022. So, assuming these data have a common growth factor, that's the same thing as a constant change factor. Growth factor, change factor is the same thing. Determine the 5-year growth factor and the 5-year percent change. Well, since we are given already the information for 2017 and 2022, that is a change of 5 years. So if we find the change factor, the multiplier, from here to here, that's the 5-year change factor, the 5-year growth factor, the 5-year multiplier, we could say. So in order to find that, we take 60.4 and divide by 43.8, and that gives us 1.3790. So that tells us that every 5 years, the number of iPad units shipped globally is 1.379 times as large as it previously was. If I change that to a percent, that would be 137.90%. So that tells me that every 5 years, the number of iPad units shipped globally is 137.9%, as much as it was before. So my 5-year growth factor, just clarifying here, is the 1.3790. And from that, I can find my 5-year percent change by first changing the growth factor to the percent, which is 137.9. Then I subtract out the original 100% that I started with, and I find out that the increase, the 5-year percent change, is 37.9%. So every 5 years, the number of iPad units shipped globally increases by 37.9%. All right, so that's the 5-year percent change. That's the 5-year growth factor. So now the next question is, what is the 1-year growth factor and the 1-year percent change? And in the last slide, we saw how to create the 1-year growth factor from a multi-unit growth factor. And the way we do that is we take the growth factor and raise it to the power of 1 over n, where n is your multi-unit. So in this case, 5 was my multi-unit. So 1.3790 raised to the 1/5 power, because we need 1/5 of the factor, gives us 1.0664. So this tells us that every year, the number of iPad units shipped globally is 1.0664 times as large as it was the previous year. And I can then change that to a percent. That's 106.64%. So each year, the number of units shipped globally is 106.64% of what it was. When I subtract out the initial 100% that I started with, that leaves me with a percent change of 6.64%. So every year, the number of iPad units shipped globally increases by 6.64%. That's my 1-year percent change, which corresponds with my 1-year growth factor of 1.0664. Okay, now it says write 2 equivalent functions that model the situation. The easiest function we can write is always when we know that vertical intercept. So we could use this reference point right here, which is the vertical intercept, and we could use this 1-year growth factor that we just created, and we can write the function as n of t equals 43.8 times 1.0664 raised to the t power. We could also use this same reference point, but instead use the 5-year growth factor. And when we do that, we would say n of t is equal to 43.8 times 1.3790 raised to the 1/5 to the t. And that's because 1.3790 raised to the 1/5 is equivalent to 1.0664. So we're using that 5-year number, but we have to remember that we want to be able to find it for each year. Now, that's also commonly written using laws of exponents. We can rewrite that in the way we see it more frequently. Let me just kind of make myself a little room here. And the way we would more commonly see that written is n of t is equal to 43.8 times 1.3790 raised to the t over 5 power. Because rules of exponents say we combine these exponents in this fashion. Okay, so those are the different ways we can write this function using this reference point. What if we used this reference point instead? We would just have to take into account that we have shifted by 5 units. And so the way that would be written is n at t is equal to that output reference times the 1 unit change factor, or the 1-year change factor. And now our exponent is t minus 5 because we're accounting for the fact that we are 5 units shifted to the right. Again, we could write that using the 5-year change factor, same way we did before. 60.4 times 3790 to the 1/5 power, just like before, t minus 5. And then when we combine these exponents, we get n of t equals 60.4 times 1.3790. Let me just move that a little bit over so I have room to put the exponent on. And now when I combine these exponents with multiplication, I get t minus 5 over 5. And that 5 in the numerator is because I've shifted 5 to the right, and the 5 in the denominator is because I'm working with the 5-year change factor instead of the 1-year change factor. Okay, the next thing is determine the expected number of iPad units to be shipped globally in 2027. In 2027, T would equal 10. And so we could pick any one of those 4 functions that's written up there and find out that n at 10 is equal to, let's take this one, to the 10th power. And that will give us an answer of 83.31. So 83.31 million iPads will be shipped in 2027. shipped globally. Now, if you choose one of the other formulas, you might get a little bit of a different answer, and that would be only due to the rounding that occurs when we find the different change factors.